as a discipline, you have to have a process for managing software changes and hardware changes in the industrial controls environment. Has to have a documented method, there has to be a process, there needs to be an approval chain, and there needs to be a method of capturing history when change occurs. And if you think about it, disaster recovery and change control are linked, right? So every time I make a change, I better make a backup to that change, because that allows me to have a disaster recovery plan for those assets. Actually, a lot of these are linked, not just those two, but those two are strongly correlated. Line of sight. This has been an area that we spent a lot of time discussing, because in general our policy within Ford, this applies not just to Powertrain but also to the VO team as well, is that we don't allow external access to our internal networks. And this is a very, very powerful area for us, because it allows us to keep separation of the controls networks from the plant networks, as well as the OA main network that people, computers sit on, even in our offices. So we don't, in general, allow external access to internal networks, and we're defining that as part of our line of sight policy. The center circle here in the top is virus and malware protection. So computers that are deployed in industrial controls environment have to have malware protection, have to have virus protection as a standard going forward. Most of the computers that we've deployed in the last 10 to 12 years within Ford don't have that. And we have demonstrated cases where viruses have popped up on computer control systems where we've seen production loss associated with those events. So this is a very, very important area for us, and we're spending a lot of time and energy fixing the ills of the past when it comes to not having virus and malware protection on computers. Access controls is another area that we're dealing with. Passwords. I mean, you guys around the room have to have the same recognition of this as we do, is that there are thousands and thousands of passwords we deploy in our manufacturing systems. Who's managing them? Who's ensuring that the user IDs are legitimate? Who's ensuring that the passwords meet IT policy around encryption and change frequency? So access control is another hot button for us. End of life, which is related to obsolescence. I'll talk more about that one in some downstream slides. And then technology management. You have to have a plan, a technology cycle plan, technology standards that you deploy. So all of these elements of IT policy apply in industrial controls. And what that's driven us to is the creation of policies and procedures for manufacturing engineering and our Tier 1 supply base that we buy equipment from. So this isn't just affecting us. This is affecting the Tier 1s and the Tier 2 suppliers that source the hardware. So zooming out, let's talk about attacking the problem a bit. So if I'll get to the three work streams here in a second, but if you think about what, over the last 7 years that I've been in the job of Global Controls Manager at Ford, we have really moved the needle starting 5 to 6 years ago around deploying elements of Industry 4.0 and the Internet of Things. And when I talk to a lot of various Tier 2s and Tier 1s, Ford Powertrain is actually well ahead of the game when it comes to intelligent devices, autonomous manufacturing, smart sensors, strong operator interaction capability, cyber-physical systems. Everything you see in that square there are the buzzwords I hear associated with Industry 4.0. We already have a lot of this in execution today. But with this comes a lot of technology, a lot of computers, a lot of smart devices, and a lot of software. And that's where we've got to do a better job making sure that we're protecting those assets that are actually part of that Industry 4.0 vision going forward. So really in 2010, 2009 as an organization, we created a lot of standards that pushed us in the right direction, not just in our hardware specifications, but also in our internet or plant floor network designs. And that was 2010, prior to us actually going through a huge wave of global expansion. So the good news is here that we've got a very solid Industry 4.0 Internet of Things infrastructure that we've deployed. The bad news is we've got to make sure it's protected. And that's really where the focus of this presentation is. So I want to show you an example. So this is, this guy's around here that should recognize this particular machine. This is a machine that is actually currently on one of our Tier 1's shop floors. That is a case and converter marriage station. So you look at that machine at this 3D view, and it's really hard to see, but you would not believe the amount of intelligence and the amount of control systems that are deployed on this machine. Right, you see a robot there. There's another hidden robot over on the left-hand side. There's an RTV dispense. There's dual robot controllers. There's 3 work positions. There's servo systems. There's HMIs. I mean, here's another view of it here. You can see that little robot hidden in the top corner there. This is a complicated station, but this is not atypical for us. This is the kind of stuff that we're deploying, the kind of technology that we're pushing out, into the manufacturing environment. And the question then becomes is how do I ensure that I've got security standards on everything that's in this one cell, right? Very, very complicated station. And this gives you an idea from a controls architecture how complicated it is. So we've got 3 station controllers. We've got, like I said, an RTV dispense robot has its own controller, right? We've got an RTV dispense system that has its own controller and a PC. So that little Dynex, Dynex in the audience here, that little Dynex PC in the lower left-hand side. Then you've got gear mesh servos. You've got a complete network architecture, which is in green, our Profinet. We love Profinet at Ford, remember that. A trafficking robot that's doing material handling, and then a vision system. So you take a look at that controls architecture, and this is even at a high level, and you say, that's a lot of technology, that's a lot of smart devices, that's a lot of computing horsepower, and that is aligned to where Industry 4.0 and the Internet of Things is going. All these devices are talking to each other, and a lot of these devices are producing information that's going into our IT backend databases. It's a different topic that we could talk about later on, but this is the kind of complication that we're dealing with. This is the kind of complication our Tier 1s are dealing with. Very, very, very complicated station. And I'm showing this as an example just to give you an idea of how many computers we're deploying on a station like this. So let's step back a little bit here. When we started looking at this problem back in 2014, we really kicked off two work streams. One of them was between manufacturing engineering and plant operations, the plants. And the second one was between manufacturing engineering controls and IT. And these 2 work streams have been converging to an end result I'll share with you here in a second. But we led this out of the controls community, and it's been painful. It's been very painful, actually. It's taken years off my life, probably. But the end result has actually put us in a much, much better place. So when it comes to the first work stream I want to focus on, which is manufacturing engineering and operations, one of the first things we needed to do back in 2014 is find out what we've got in the plants. And you would think this would be an easy task, right? And I thought it was going to be an easy task. So we put together this nice spreadsheet, Excel spreadsheet, and we sent it to all the plants and said, fill this out. What we got back was a bag of garbage. Because if you're not very specific as to what you want the plants to do, they're going to do what you ask them to do, especially in this area around PCs. But we had to be prescriptive, very prescriptive on the data set that we needed to get back from the plants, and we weren't. So we took a shot at this. We had, not just powertrain, this includes stamping and VO now, 72 global facilities. What we got back was all different, and the Excel's good and Excel's bad, because part of the problem with Excel is it's freeform. So we had people making up their own field names, inserting columns, and when you're trying to consolidate reams and reams and reams of information, you have to have a nice set of standard fields, definitions, and descriptions on what you're asking the plants to do. So what I showed you right here was what ended up being the end result as far as the data set that we went after. So certainly the easy stuff, the region, the plant, the production line within the plant, but then you get into some of this more difficult stuff. What network is this PC on, right? What's the IP address of that PC? Do you have a hardware backup? Do you have a software backup? Do you have passwords that you're using on those computers? What happens if you lose that computer? Are you losing production? Are you losing quality? What are you losing when you lose that computer? Do you have an antivirus solution or malware protection? And then you get to this next one. What's the operating system? I had to actually use 2 rows to put all those on. One of our #1 problems that we're facing is the churn of the operating systems on these computers and on the intelligent control systems. We have DOS boxes out there in our plants today. We have Windows NTs. My management thinks all that's gone. I don't know how my management's here. But they think that we got rid of all those NT devices. We did, right? You know, I found out early on in this is that we have some of our high-tech storage and retrieval systems that are running OS/2. Right? How do you manage that change and that churn of these operating systems? How do you create disaster recovery? How do you manage software backups? It's a huge challenge. Then, does it have a USB? Does it have a floppy drive? I think a lot of people think floppy drives are gone. Not in the plants, they're not. No. CD.